20 trillion gallons. I want you to sit with that number for a second before we go any further, because it is not a typo, and it is not some exaggerated figure I threw on a thumbnail to get you to click. That is a real, documented, scientifically calculated amount of water that fell on the state of California in a single stretch of weeks. It was delivered by a chain of storms so relentless, so back-to-back, so unforgiving, that meteorologists genuinely ran out of ordinary language to describe what they were watching unfold. They had to reach for a new phrase, one that is now permanently stitched into California's weather history, and that phrase is an atmospheric river siege. Today, I want to walk you through exactly what that number actually means, how something called a river can literally exist floating in the sky above an ocean, and why California's own state fire and weather agencies just quietly published a forecast flagging that a pattern very much like this one is considered likely again this coming fall and winter. I need to be clear about something right up front. This is not a story about water falling on California today. This is a story about a number so enormous it is almost impossible for the human mind to picture what it actually did the last time it happened, and why the very people whose job it is to plan for the next one are already watching the sky right now, in the middle of August, months before anything is even close to forming. So stick with me all the way to the end, because I'm going to show you exactly how meteorologists arrive at a number like 20 trillion, and why it is not the wild, made-up guess it might sound like at first. Let's start with the number itself, because before we talk about what it actually did to the state, I want you to genuinely understand what 20 trillion gallons of water even is. On its own, it is simply too large a figure for a human brain to process in any meaningful way, so let's build a picture instead. Imagine a flat surface exactly the size of the entire state of California, all 163,000 square miles of it, every mountain range, every valley, every stretch of desert, and the entire coastline included. Now imagine covering that entire surface, all of it at once, in more than half a foot of standing water. That is the volume we are talking about here. That is what fell. During a run of storms in early January of 2023, an atmospheric science student at UC Davis actually sat down and ran the real math on this, using rainfall totals pulled directly from the National Weather Prediction Center. That calculation relied on a standard hydrology conversion, the kind used across the water management field, where a single inch of rainfall falling over 1 acre of land equals approximately 27,154 gallons of water. When you multiply that conversion out across California's roughly 8.61 inches of statewide average rainfall during that stretch, and you apply it across every single acre in the state, you land on a figure that is genuinely staggering, somewhere between 22 and 25 trillion gallons of water delivered to a single state in about 16 days. And this wasn't just an academic exercise sitting in a university paper somewhere. California's own governor cited an extremely similar number publicly, telling reporters directly that the state had received between 22 and 25 trillion gallons of rain since that storm sequence had begun. He was not speaking in hypotheticals when he said that. He was standing in front of a state that had just been hammered by 9 separate atmospheric rivers, arriving one after another, back to back, with federal disaster declarations already being issued across multiple counties as he spoke. So now let's actually talk about the mechanism behind all of this, because the phrase atmospheric river sounds, on the surface, like a poetic exaggeration, some kind of dramatic weather buzzword. I want you to understand that it is the exact opposite of that. It is a precise, technical, measurable meteorological phenomenon, and once you understand how it actually works, that 20 trillion gallon number stops sounding impossible and starts making complete sense. An atmospheric river is a long, narrow corridor of concentrated water vapor flowing through the sky, typically stretching all the way from the tropics out toward the coast, carrying enormous quantities of moisture at a relatively low altitude. According to NOAA, a single strong atmospheric river event can transport an amount of water vapor roughly equivalent to the average flow of water at the mouth of the Mississippi River, one of the largest rivers on the entire planet. Except this version of that river is completely invisible, moving silently through the atmosphere instead of carving out a riverbed on the ground, right up until the moment it slams directly into the coastal mountains of California. And once that happens, all of that moisture has nowhere left to go but down. When that plume of moisture hits the Sierra Nevada or the coast ranges further west and gets forced upward by the terrain, it cools rapidly, and all of that suspended water vapor condenses almost instantly and falls as rain or at higher elevations as snow, and it falls in enormous, sustained quantities. Meteorologists actually grade these events on a numbered intensity scale, similar in spirit to how we categorize hurricanes. That scale runs from a relatively weak AR1 all the way up through an extreme AR5, and the rating is based on both the intensity of the moisture transport and how long the event actually lingers and lasts over a given location. Here is what made the January 2023 sequence so genuinely exceptional. And here is exactly why the 20 trillion gallon figure became the number everybody remembers from it. It was not one atmospheric river, it was 9 of them, arriving back to back to back, in less than a single month. Each new storm added itself on top of ground that had not had any real time to dry out or drain from the last one. California's governor described this at the time using the word stacking, and he said it was stacking the likes of which the state had not experienced in living memory. He said that during the middle of what turned out to be the 8th storm in that sequence, with a 9th already visible and on the way behind it. That stacking effect is the real story hiding behind a number that large. Any single atmospheric river, even a genuinely strong one, might drop a few inches of rain over the course of a few days on its own. But 9 of them, one right after another, with no recovery window in between, is exactly what turns a normal, healthy wet season pattern into a historic, statewide 20 trillion gallon event. I want to spend a moment on that scale rating I mentioned earlier, because it actually matters for understanding why 9 of these storms in a row is such a different animal from 9 ordinary rainy days. A weak AR1 event might just bring a beneficial, gentle soaking to the coast, the kind of rain that farmers actually want, and that barely makes the evening news. But as you move up that scale toward an AR4 or an AR5, you're talking about extreme, hazardous conditions, the kind capable of producing widespread flooding and significant damage all on their own, even without any help from a second or a third storm stacked right behind it. During the January 2023 sequence, several of those 9 storms were rated in that stronger range. And when you stack multiple strong to extreme events back to back, with saturated ground and swollen rivers left behind from the one before it, you get a compounding effect where each subsequent storm does more damage than it would have on its own, because the landscape underneath it has already lost its capacity to absorb anything more. That is the mechanical reason stacking is so dangerous. It is not simply 9 storms adding their totals together in a spreadsheet. It is 9 storms each, making the ground less and less able to handle the next one. Now, I want to be completely honest with you about what that much water actually did to the state, because the raw number, however staggering it is on its own, does not tell you the whole story by itself. That January 2023 sequence killed at least 18 people, according to California's own Office of Emergency Services at the time. It caused roads to partially collapse. It flooded entire neighborhoods and forced thousands of people to evacuate their homes with very little warning. And here's the part of this story that I think deserves real, genuine emphasis, because it is the piece that so often gets lost the moment a headline goes chasing after a big, scary number instead. The exact same storms that killed people and destroyed property also, within a matter of weeks, pulled California almost entirely out of a drought emergency that had gripped the state for years. Before those storms ever hit, roughly 43% of California was officially classified under extreme or exceptional drought conditions. Within about 3 months, the U.S. Drought Monitor showed the state with absolutely no areas remaining in either of those 2 categories at all. The state's 2 largest reservoirs saw their combined storage increase by 66%. 27 million people ended up receiving more water than they had originally been allocated just a single month earlier. That is the genuinely strange, 2-sided nature of an atmospheric river siege. The exact same event can simultaneously be the most dangerous weather disaster a region has experienced in years, and also the very thing that ends a multi-year drought emergency almost overnight. So now, let's talk about why I am bringing all of this up right now, in the middle of August, when nothing resembling this is actually happening on the map today. It is because California's own state fire and weather agencies just published their seasonal outlook for the months immediately ahead of us, and it is genuinely worth understanding what they are already flagging, well before the wet season has even begun to turn. The Southern Operations Seasonal Outlook, issued at the end of July and covering the period from August straight through November of this year, explicitly states that as the state transitions out of its dry season, conditions are expected to run warm, and that atmospheric rivers are considered likely as the wet season gets underway. I want to stress, this is not some dramatic prediction pulled out of nowhere for shock value. This is the kind of routine, technical seasonal assessment that fire and water agencies produce every single year to help plan resource allocation. And this particular year's version specifically calls out the same exact phenomenon that was responsible for that 20 trillion gallon event back in January of 2023. So let's talk about why forecasters are already thinking about this months in advance, because the reasoning connects directly back to the mechanism I explained a little earlier. Atmospheric rivers form when there is a strong, persistent plume of tropical or subtropical moisture that connects up to a storm track capable of funneling that moisture directly toward the California coast. The strength and the frequency of that setup from one year to the next depends heavily on the broader state of the Pacific Ocean. And that includes exactly the kind of El Nino pattern that has been shaping weather stories all across multiple other systems this year. The same El Nino pattern that has been suppressing Atlantic hurricane activity elsewhere has real, direct implications for the storm track that eventually determines just how active California's atmospheric river season becomes once fall and winter finally arrive. It's worth understanding just how far-reaching that single ocean pattern actually is, because it's easy to think of El Nino as just a Pacific phenomenon that stays contained to one region, when in reality it reshapes the position of the jet stream across the entire globe. That shifted jet stream is precisely what can either aim a parade of moisture-laden storms directly at the California coast, one after another, or instead steer them further north or south, sparing the state from that kind of relentless stacking. Forecasters don't just look at whether El Nino is present or absent, they look at its strength, its exact configuration, and how it's interacting with other ocean signals at the same time. Because a weak El Nino can produce a very different California wet season than a strong one, even though both would technically qualify as an El Nino year. Forecasters watching sea surface temperature anomalies and the broader Pacific pattern right now are doing exactly what allowed them to see the January 2023 sequence coming with real lead time, all the way back in December of 2022. They are reading the large-scale ocean and atmospheric setup for the same telltale signs that tend to precede an active or even a historically extreme atmospheric river season. Now, I want to be careful here, in exactly the way I try to be careful with every story like this one, because there is a meaningful, important difference between saying atmospheric rivers are likely this wet season, which is what the current outlook actually says, and saying a 20 trillion gallon mega event is confirmed to be coming, which it very much does not say. Every single California wet season includes atmospheric rivers to some degree. They are not some rare anomaly. They are, in fact, the primary mechanism by which the state receives the majority of its annual precipitation in a completely normal year. What varies enormously from one year to the next is how many of them actually arrive, how intense each individual one turns out to be, and critically, whether or not they end up stacking back to back the way they did in January of 2023, without enough recovery time between each event for the ground to properly drain and for reservoirs to safely absorb the next incoming pulse of water. That stacking behavior in particular is genuinely difficult to forecast with high confidence more than just a few weeks out, even in a year where the broader seasonal outlook correctly identifies that overall conditions favor an active atmospheric river pattern. Here's the part of this whole story that I think deserves the most attention of all, because it connects everything we've talked about back to what actually matters for people living in California right now in August, with the wet season still months away. A 20 trillion gallon event is not purely a weather story. It is a water management story. It is an infrastructure story. And in the years since 2023, it has become a genuine, serious planning priority for the entire state. California has spent real, sustained effort since that historic storm sequence working on capturing more of that floodwater, rather than simply letting the vast majority of it run straight off into the ocean and go to waste. That is because the same state that watched 18 people die in flooding back in January of 2023 also watched a years-long drought emergency essentially come to an end within that very same 3-month window. Think about what that actually means from a planning perspective for a moment. The state's engineers and water managers are essentially trying to solve a puzzle where the answer keeps changing shape depending on how the storms arrive. If the same total volume of water fell as one long, gentle, spread-out season instead of 9 violent pulses crammed into less than a month, the outcome could look almost entirely different. Less catastrophic flooding, less loss of life, but also potentially less water actually captured for long-term storage, because a slow soak behaves very differently in the ground than a flash of runoff racing downhill. That is part of why the effort since 2023 has focused so heavily on infrastructure that can move quickly, floodplain projects that intentionally let rivers spread out and slow down rather than channel everything straight toward the ocean, and groundwater recharge basins designed specifically to take advantage of exactly the kind of short, intense bursts that stacking storms tend to produce. And the lesson that state water managers took away from that whiplash experience is that both outcomes, catastrophic flooding on one hand and drought-ending relief on the other, are very often riding in on the exact same storms. The difference between disaster and relief frequently comes down to timing, how saturated the ground already is, and how much of that incoming water the state's reservoirs and groundwater basins are actually equipped to capture and hold on to, rather than simply letting it flood downstream completely unused. So where does all of this leave things right now today? Honestly, California is currently sitting in its dry season, the very same dry season that the state's own fire outlook describes as carrying near normal wildfire potential right through the fall months. There is no current atmospheric river event underway anywhere, and nothing resembling that 20 trillion gallon siege from January of 2023 is anywhere on the map today. What is true, and what the state's own forecasters are already on record about, is that as this current dry season transitions into the wet season over the coming months, atmospheric rivers are considered a likely feature of that transition. That expectation is shaped in part by the very same broader Pacific Ocean patterns that have been driving weather stories across the entire country all year long. Whether this coming season ends up producing a routine, perfectly manageable series of storms, or instead turns into another historic stacking event like we saw in January of 2023, is something that will only become genuinely forecastable with real confidence as we get much closer to the season itself, typically within a lead time of about 1 to 2 weeks, once a specific atmospheric river event actually begins forming. Let me bring this back to something practical, because that is always the real point of walking through a story like this, instead of just repeating a scary number over and over for effect. If you live in California, this is a genuinely useful moment right now, while the state is still in its dry season and before any specific storm is anywhere on the map, to actually think through your household's flood and storm preparedness, rather than waiting until an atmospheric river warning is already active and the clock is already ticking. That means taking the time to know whether your home sits in a flood-prone area. It means understanding your specific property's landslide risk, especially if you happen to live anywhere near hillsides that were burned during recent wildfire seasons, since those burn-scarred slopes lose the vegetation that would normally hold the soil in place during heavy, sustained rainfall. And it simply means being genuinely aware that California's wet season, whenever it arrives, has a well-documented history of swinging rapidly from drought relief all the way to genuine emergency within that very same sequence of storms. And none of that requires you to believe that some specific mega event is already confirmed for this coming winter. It just requires taking the state's own seasonal outlook seriously, the exact same way you would take a hurricane outlook seriously if you lived along the Gulf Coast, without needing a specific storm to already be sitting on the map. There's a reason emergency planners keep repeating that comparison to hurricane season, and it's worth sitting with for a second. Nobody along the Gulf Coast waits until a named storm is spinning in the water to figure out where their flood insurance documents are kept, or whether their gutters are clear, or which route they'd actually take if evacuation orders came through. They do that groundwork in the calm months, precisely because doing it under pressure, with a storm already bearing down, is when mistakes get made and when people get hurt. California's atmospheric river season deserves exactly that same mindset. The months between now and whenever that first strong system actually forms are the only window where preparation is calm, methodical, and genuinely effective, rather than rushed. I think it's worth pausing here and really sitting with just how wide that gap is between the disaster half of this story and the relief half of it, because both of them are equally true, and both of them happened because of the exact same 9 storms. 18 families lost someone they loved. Roads collapsed under the weight of runoff that had nowhere left to go. Entire neighborhoods watched water rise into homes that had never flooded before. And at the very same time, in that very same window, a drought that had strangled farms, drained reservoirs, and forced water restrictions on tens of millions of people for years, essentially evaporated, no pun intended, in about 90 days. That is not a contradiction. That is simply what an atmospheric river siege actually is, one continuous weather event that manages to be 2 completely different stories, depending entirely on where you happen to be standing when it hits. And that duality is exactly why the state takes a seasonal outlook like the one just published so seriously, even in the middle of August, even with the ground bone dry and wildfire crews still gearing up for a near-normal fire season. Because the agencies writing that outlook already know, from direct recent painful experience, that the difference between a wet season that quietly refills the reservoirs and a wet season that kills people and destroys neighborhoods often comes down to nothing more than how many of these atmospheric rivers show up, how close together they arrive, and whether the infrastructure on the ground is ready to catch what falls instead of just watching it rush past. That is genuinely the story here, not a specific storm, not a confirmed repeat of January 2023, just a seasonal outlook written in dry, technical language by people whose entire job is to plan months ahead, quietly noting that the same ingredients that produced a 20 trillion gallon siege once before are the same ingredients considered likely to be in play again this coming fall and winter. Whether this upcoming season ends up looking like a normal, healthy wet season or another historic stacking event is genuinely unknown right now, and anyone telling you otherwise with total confidence this far out is guessing. But the pattern being watched, the mechanism behind it, and the sheer scale of what it is capable of producing, all of that is very real, and all of that is worth understanding now, while there's still time to prepare, rather than scrambling to catch up once the first storm actually appears on radar. Before you go, I want to ask you something, because I think California's atmospheric river story is genuinely one of the more fascinating examples out there of how the exact same weather event can be 2 completely different stories, depending entirely on where you're standing when it happens. If you lived through the January 2023 storms yourself, or if you remember hearing about them at the time, does that 20 trillion gallon number register with you more as the disaster it caused or as the drought relief it ultimately delivered? Drop a comment and let me know, because I genuinely think that split says a lot about how complicated it actually is to cover a story like this responsibly, instead of just picking whichever half of it happens to be more dramatic. If this gave you a clearer picture of what that number actually means and what is genuinely being watched for as this coming season approaches, go ahead and hit that like button. Because it genuinely helps grounded, accurate breakdowns like this one reach more people instead of the recycled, scary headlines that get thrown around completely detached from what's actually happening on the calendar. And make sure you're subscribed so you're here the moment this fall's wet season pattern actually starts to take shape. Because I will be tracking it from the very first system that develops, all the way through, exactly the same way I walked you through this one today. Drop your thoughts down in the comments. Let me know which side of this story hits you harder, the disaster or the relief, and I will see you in the next one.